Clustering. Clustering in computing refers to a technique where multiple servers or nodes are linked together to work as a single unit to improve performance, availability, scalability, and fault tolerance. The primary goal of clustering is to ensure that if one server or node fails, another can take over, providing uninterrupted service and ensuring high availability. In a cluster, tasks like handling requests, data storage, or running applications are distributed across multiple nodes, which operate in coordination to achieve a common goal. Clustering can be used for various purposes, such as load balancing, database management, high performance computing, and fault tolerance systems. There are multiple types of clustering. I guess the most famous one is the clustering in the database when you use like um, a master slave relationship for the clustering. So I don't know if you know what is master slave is, but like let's assume that we have right now a big database db. Oh, let me delete everything here. A big database right now, and we want to make sure it's we only right now have one server, and if we if this one failed over or had anything, the full data will be lost. So we use like a master slave database, so we add more servers. For example, we have another one here, database, and another database. Oh no, another database here, db. And this is, let's see, this is the master, and this is the slave one, and this is the slave two. And basically we duplicate all the data between them, and we serve the write requests through the masters, and the read request will be through the slave. And when we, and everything is which is written into the master, it will be replicated into the slaves. And if one of them, if one of the slaves went down, we still have two servers. If the master went down, the slave will promote to be a master, and we continue. And by doing this clustering, we will make sure that our system is high available and fault tolerance, and our system is redundant. This is one of the famous technique when it comes to clustering, and this is database clustering. But there are multiple types of clustering, and I guess it's quite important to know them in context of system design interview. In this video, I'll just go on high level of them, and after that, maybe we could create a dedicated videos for each one of them. So the first one, which will be the high availability clustering. Okay. The purpose of this one is to ensure that services remain available even if one or more nodes fail. The mechanism, like these clusters, use failover techniques to switch to a backup nodes when a primary node becomes unavailable. So if we have a client and this client is connected to a server, and we have server one, basically we will have multiple nodes. Basically we have like a cluster of servers, web servers, like let's say that a backend cluster or web server cluster. So we have S2 here. So when the client is connected with S1 and S1 went down, S2 will take in charge with, and the failover mechanism will handle all of that. And by then we will achieve the high availability that we needed. So the use cases for that, it's web servers or database where downtime must be minimized. If one server in the cluster fails, another server takes over to ensure continuous availability. Number two, it's the load balancing clustering. The purpose of this one is to distribute workloads evenly across multiple nodes to prevent any single node from being overwhelmed. The mechanism that is used for that, like requests are distributed among nodes based on current load performance or predefined rule. And this use case, this is used in the larger scale web applications like e-commerce websites, maybe social media app, where traffic can spike suddenly. Clustering ensures that no single server is overwhelmed by distributing incoming requests across multiple servers. So if we have the client again and we have a lot of servers, let's say S1, 2, S5, for example. So we have 5 servers, and we will use a load balancer, which will distribute all the incoming requests to the servers to make sure that no server is overwhelmed with requests, and also no server is underused. So we'll make sure about that. Number 3, I guess we have high performance computing clusters. Let's just say number 3 or 4. Number 3, not 4. Number 3, high performance computing clusters. The purpose of this one is to provide enhanced enhanced power by distributing tasks across multiple servers or nodes. The mechanism that used for that, we use like complex computational tasks are broken down into smaller subtasks and distributed across nodes in the cluster. But I would say this is not, you will not face high performance computing clusters that much in your system design interview, but it's something that worth mentioning, and you should know that it exists. But in the context of system design interview, you don't have to know that much of high performance computing clusters. The thing that it's the opposite, and you need to know a lot about it, which is database clustering. Okay, database clustering. To distribute database tasks across multiple nodes, improving the query performance and ensuring availability. So if you remember the master-slave database that we talk about, basically the master is serving the right requests and the right operations, and the slaves serve the read operations. And by then we basically distribute the load on the servers, and also we improve query performance and ensuring high availability, because we have only two servers that should be responsible for queries, not one server in this architecture that you can see below. The mechanism that used in that data, we use database cluster use data replication, because the data is replicated across nodes or partitioned, which is sharded for load balancing and redundancy. It's a use case for high traffic e-commerce site using database cluster like MySQL or Postgres to handle millions of transactions per second, ensuring consistency and reliable access to data. There is a storage cluster, but I would say it's not. You will not face it that much in your system design interview. So yeah, I will just go through it. We need to talk about the clustering architecture, because there are some architectures that should be discussed. The first thing that we did talk about early, which is the master-slave architecture. There is a master node which is active, handles all write requests. Sometimes it handles all requests. There is a slave nodes, which is a passive. These nodes act as a backup to the master. If the master node fails, one of the slave nodes takes over. In this one, it's in this one basically the master does anything that is called active passive. So the slaves will not serve any read or write request. They are just waiting if the master has a problem, and they will take over. There is master mastem, which is active, which is multiple active nodes, which like all nodes can handle requests simultaneously. So basically, the slaves also can handle write requests and read requests, and the master can handle write requests and read requests. So if one node fails, the others continues to operate without any disruption. And also any data which has been written to any servers, it will be replicated across the other servers. And if we got any inconsistency, we use versioning and other stuff to handle that. There is also some other architecture called shared nothing, also other architecture called shared disk, but you will not face them that much. The important is to know the master-slave data, the master-slave architecture, and also to know the master-master and actually how the master-slave works. Like sometimes the master handles the write requests and the slave handles the read requests. Sometimes the master handles everything and the slave doesn't do anything. It just waits if the master got any problem to take over its place. Let's talk about some key components of clustering worth mentioning. The first is which are the nodes, because a cluster it's a set of nodes, okay, a set of nodes that act as one unit. They act like one node. So a server's cluster, it's just a set of a lot of servers that act like one server. So the individual servers or machine in a cluster, each node works with others to handle tasks, requests, or data storage, and they together works as a single unit. Number two, it's the cluster management or the cluster manager. So it's manage the coordination between nodes, handles failovers, load distribution, and ensure that nodes are operating as expected. Example for that is Kubernetes in container, and Kubernetes handle that perfectly. What other things? Nothing come to my mind. I guess Kubernetes is perfect example for handling cluster manager. It's I guess it's the most famous one. Number three of the key components is the load balancer. It's this, as we said before, it distributes the tasks and it distribute the requests and distribute the operations, and also it makes sure that no node is overwhelmed with requests and no other node is it's not used. So distribute tasks, requests, or data across multiple nodes to ensure efficient resource utilization and prevent any single node from becoming a bottleneck. I guess example for that HA proxy or Nginx, and yeah, that's it. Number four, there is heartbeat machines. Heartbeat machines. Let's call it HBM. Nodes constantly send signals, which is called heartbeats, to each other for or the cluster manager to indicate they are functioning. If one node's heartbeat stops, a cluster manager can trigger failover. So if we have, let's say that we have a coordinator here, which is we can act him as like the cluster manager, and we have, let's say that all clusters are in a hash ring. So they try to send beats to each other to know if they are, and we have a table that store the beat, the ID of the server, and what was the last time they give they give a response to heartbeat requests. And if one server doesn't respond at all, basically from the database they will send the servers or the nodes will send requests to the coordinator, and when the coordinator maybe get two requests of one server that this server doesn't work at all, it will not be in the pool, in the server's pool. So basically the coordinator will try to distribute or the load balancer will try to distribute requests among the servers. It will not send requests to these servers at all. Number five, we have a failover mechanism. When a node fails, the failover mechanism automatically shifts its tasks to another nodes to maintain server's availability. The advantage of using clustering, I guess it's mainly coming to five things. The first thing, which is high availability. Clusters ensure that services remain available even if individual nodes fails, minimizing downtime. Number two, we have scalability. By adding more nodes to a cluster, you can increase the system's capacity to handle more requests, tasks, or data. Number three, we have a fault tolerance. Clusters are resilient to failures. If one node or component fails, other can take over without impacting the service availability. And number four, which is improved performance. Workloads are distributed across multiple nodes, reducing reducing the load on individual servers and improving overall performance. There are also some challenging that comes with clustering. The first thing is complexity. It's really complex. Like setting up and manage a cluster can be quite complex, especially when dealing with failover configurations and synchronization and data consistency. Also, data consistency, like ensure data consistent across all nodes, can be really challenging, especially in systems that require real-time updates or synchronous replication. Also, there is network latency because there are a lot of communications happen between nodes. So communication between nodes over a network can introduce some sort of latency, especially in geographically distributed clusters. And one big thing also is the cost. Clustering requires additional hardware, software, and operational costs. For example, implementing a redundant hardware licensing, cluster management software, and managing complex network infrastructure. This has increased the cost a lot. And number five, which is failure handling, like if not properly configured, failover can lead to data loss, inconsistent state, or performance degradation. So basically, in conclusion, clustering is a powerful technique for improving system availability, fault tolerance, and performance. By distributing tasks and workloads across multiple servers or nodes, clustering ensures that if one node fails, the system remains operational, making it an essential architecture for mission-critical applications, databases, web services, and high-performance computing environments. However, clustering introduces complexity, requiring careful planning, implementation, and management to ensure that the system performs optimally and handles failure gracefully. So that's it for this video, and see you in the future.